How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at diamagnetism and paramagnetism. So our objectives will be to determine if a molecule is diamagnetic or paramagnetic and describe the properties of each. So let's get rolling. So paramagnetism, what is it? Paramagnetism is when molecules with one or more unpaired electrons, they're going to be attracted to a magnetic field. So an example could be the O2 molecule. Right, so in this picture we have liquid O2 being poured between two magnets. And you can see that they are attracted to the magnetic field. Now why is that? It's because they're paramagnetic. The more unpaired electrons we have, the more attracted to that magnetic field they will be. And if you look at the molecular orbital diagram, you can see that oxygen has two unpaired electrons. So it's going to be paramagnetic, because it's attracted to the magnetic field. Now, a special note, oxygen's Lewis structure doesn't show any unpaired electrons, right? If you look at the Lewis structure right here, everything seems to be paired up, but oxygen still is attracted to a magnetic field. Why is that? How could that be? And this is where the molecular orbital theory does a better job of explaining its properties, right? You can see in the molecular orbital diagrams, there are two unpaired electrons, which would explain its paramagnetism. Now, diamagnetism is when substances with no unpaired electrons are weakly repelled from a magnetic field, which I always found really interesting. So if we take a look at N2's molecular orbital diagram, you can see all of these electrons are paired up. There aren't any unpaired electrons. So when you have a magnetic field near a nitrogen molecule, it's going to repel weakly that nitrogen molecule. Instead of being attracted to the magnetic field, it's going to be repelled by it. Now, this is a much weaker force than paramagnetism, just so you know. So, try it out. Figure out which one of these are paramagnetic and which ones are diamagnetic. Here's a little hint. For whatever reason, paramagnetic, I think it should be called unparamagnetic, right? Because it's unpaired electrons. Or you can think of the word diamagnetic. Di means two, so it's going to be the one where electrons are paired up. So take a look at these molecular orbital diagrams and figure out which ones are paramagnetic and which ones are diamagnetic. All right, well, if taking a look at B2, you can see there are two unpaired electrons, so it would be paramagnetic. It's going to be attracted to a magnetic field. Whereas C2, all of these electrons are paired, so it would be diamagnetic. Now, I also remember, well, which one of these refers to being attracted to a magnetic field and which one's repelled? I think of diamagnetic as like just screaming like die towards the magnetic field. So diamagnetic, paired electrons, hates magnetic fields, right? All right, so N2 also going to be diamagnetic because they're all paired up. Oxygen, paramagnetic because we have these unpaired electrons. F2, diamagnetic because they're all paired up. Ne2, if it existed, would also be diamagnetic, but I'm going to say, this is kind of a trick question because it doesn't exist. You're not going to find an Ne2 molecule. All right, so summarize. Can you determine if a molecule is diamagnetic or paramagnetic and describe the properties of each? I sure hope so. Okay, bye.